Here's another video in my little series on explaining probability and statistics ideas and the maths behind them and doing the calculations quickly. So this video is on binomial probability distributions and the properties of a binomial distribution, by which I mean the mean and standard deviation, although I'm going to calculate the variance here because it's easier to do. Okay, here's an example then. We've got a probability tree. Well, what have we got in a binomial? Well, we have two outcomes, B for bi. In this case, it's rolling a 6 or not rolling a 6. And then we have a probability, P, of rolling a 6. And then we have our complementary probability of not rolling a 6. So that's 1/6 for rolling a 6, 5/6 for not. And then we've got a series of trials, in this case 5 trials, but this is basically an n trial model, and each trial is independent and each one has the same probability. So let's have a quick whiz through and look at firstly what our mean or expected value is. Well, intuitively it's 5/6, doesn't it? Because we've got 5 rolls and we've got 1/6 is the probability of rolling a 6. So that's NP, isn't it? But let's prove it. So in effect, this is the mean is a weighted average. So what we could get we could roll 5 6s, and here's the probability of that, 1/6 to the power 5. We could get 4 6s, and that's the probability, 3 6s, and that's the probability. So you can see how that builds up. And finally, we could get no 6s, and that's the probability of that, which of course that term's going to be 0. So having got our 0 term there, we started off with 6 terms and we're now down to 5. And what we do find is that 5 is a factor and 1/6 is a factor. So look, there's our NP out the front. And then we form a bracket with the rest of this. And if you have a quick look, we've got our P here and P to the 4 there and a PQ there. And look at our powers, coefficients, 1 4 6 4 1. Well, that is a complete binomial expansion, isn't it, of 1/6 plus 5/6 to the power 4. Well, 1/6 plus 5/6 is 1, so 1 to the power 4 is 1. That just leaves us our 5/6 behind. That's our NP. Here it is in more mathematical terms in the green here. So expected value is 5 6s, and that's the probability, 4 6s, and that's the probability, etc. There's the probability, sorry, 3 6s, and that's the probability. Here again, that last term is 0, there it is. So that our NP comes out as the factor at the front. So here's our P to the 4, there's our 4 choose 1, P3 Q1. So as you can right through to our Q to the 4, so there's our perfect binomial expansion. There's P plus Q to the power 4, which is going to be 1. That just leaves us our NP, doesn't it? So there we are. The mean is going to be NP. So what's our variance going to be? Well, we've got to get our expected value of x squared, and then we've got to correct a bit later on for the fact that our mean isn't 0. So as we did before in the green, we've got our n squared here. So that's our probability that if we had this n times, that would be 5 in this case, 5 squared. Yeah, so we could roll the dice 5 times, and our probability of getting 5 6s is n is there, and that's 5 squared. So there's our n squared. There's 4 squared for 4 6s and 3 6s. So we've got the same thing here, except we've got a square out the front. Okay, so once again, this last term is 0. There it is. And once again, NP is going to be a factor all the way through, so we can bring that out the front. But now, what we've got left over inside this bracket isn't a perfect binomial, is it? But it looks like the sort of form. So let's split it up, shall we? We could split out the binomial, which we'll know is going to be in a 1 4 6 4 1 coefficients, and let's see what's left over. Well, if we do that, we get left over with 4p to the 4, and then we get left over with 12 p cubed q to the 1, and oh look, there's a 12 and there's a 4. So what have we got there? Look, we've got on the purple side, we've got a factor of 4p going all the way through, so we can bring that out the front. And what have we got left now? Oh, we've got a nice perfect binomial, a 1, 3, 3, 1 in P and Q. So writing that out, our blue bracket becomes P plus Q to the power 4, and our purple becomes 4P times P plus Q to the power 3. Here P plus Q is 1 because that's true of all probabilities, so there's our 1 to the 4 there, and there's our 1 to the power 3 there. And so our next line in all of this is we've shown that e to the x squared is np, that's our factor out the front, our 1, and our n minus 1p. Where do we get the n minus 1 from? Well, that 4, where did the 4 come from? Well, in this case our n was 5, so that's n minus 1, so I've written it back in its proper terms. So in general terms, that's our expected. Well, what's the variance? Well, that's our expected value of x squared, and then we've got to correct for our mean, which in this case is np, and we have to do np squared. So dropping our equations from earlier in, that's directly above the x squared, and there's our np squared. Where if we expand that, our n squared p squared is going to cancel out, and we're going to get left with this term here, the 1, and we're going to left with this minus 1p over here. So that's minus p, which lo and behold is q. So there's our variance, npq, and that's proved our binomial distribution, which we would write, which I haven't written here, as binomial n and p. Our mean is np, and our variance is npq, which means our standard deviation is going to be square root of npq, and the definitions of them all are below. So there we are, and that's how we get the properties of a binomial distribution. Thank you very much.